Hello, everyone. Welcome to this session. My name is Yusuf Yildiz, and I'm working as a solutions architect in LINBIT. It is a fancy title for pre-sales technician these days. And I will try to explain our solution, open source software-defined storage, Linstor, to you guys today. So before I explain Linstor, I will quickly introduce who LINBIT is, because LINBIT is an old company, but it's not very known in the industry, especially when it comes to the new generation. So LINBIT is a Linux open source block storage pioneer. By pioneer, I mean it because LINBIT has been in this area since 24 years. And I will explain, we have some softwares like Drbd and Linstor since many years, and the Drbd is in the Linux kernel since 2009. So if you ever run a Linux machine since 2009, most likely you already have our software already installed in it. And we currently hold the IOPS world record. I will also get to the numbers later on. So why LINBIT? Because we always aimed for the high performance for our customers because of our replication technology, Drbd again. And we focus on lower TCO because the thing is, everything we provide, everything we produce in the company is open source, and we don't sell any license to any customers. What we sell is our support subscriptions, and they are fairly cheap when you compare with the competitors. So it will always keep your TCO down in the charts. And the Linstor and our software can easily scalable. We have customers like have thousands of nodes in one single cluster. Again, thanks to the beautiful design of Linstor and the Drbd. Again, I will explain in a minute. And open source, I just mentioned. I mean, you can install it anywhere. It can be in VM, a bare metal, or whichever, a Raspberry Pi, whatever you think of. You can put it into a couple of machines off the shelf, and then you can have a storage device without worrying about what will happen if this hardware will run out of time, end of life. And again, the low latency and low CPU usage is one of the key things of Drbd is having as a feature set. It will only impact 0.5% per resource, which is literally nothing when you compare with the competitors. And failover pods in seconds. This is one of the features which Linstor has. You can simply failover pods between the nodes with live migration or offline. It's your choice, but in seconds, your pods will be rescheduled between the worker nodes. And the key facts about LINBIT, we have approximately 3 million users all around the globe. These numbers are coming from our servers that we are counting how many users are downloaded our software. So this is a rough numbers, obviously, because we don't know who are using actually our solution. A couple of days ago, I was in Hamburg with another ContainerDays event, and somebody came to our booth and he said, "I just want to thank you." And I said, "Okay, thank you so much, but why?" And he said, "We were using your software since, I don't know, 8 years, and in 800 nodes. And we didn't know it. I mean, he just used it without any issues, without any problems, and he just come by to say thank you to us. So this is really valuable for us. But again, we don't know how many users are actually using it at the end because it's an open source software. And 40 million downloads, different types of downloads, our software. And just I mentioned 25.5 million IOPS. World record is, holder is the Linstor. I can share the link after this session if you like in our booth. This is the solution overview of Linstor. So no matter, if you would like to have a software-defined storage or persistent storage for your Kubernetes, hyperconverged or some sort of disaster recovery in your mind, or high availability or high performance block storage, it doesn't matter. Linstor covers it all. And we have drivers, APIs, and different sets of integrations with different platforms, and Kubernetes is one of them, actually the leading of platforms in terms of platforms. And the Linstor provides block storage to all of them. Let me put a pause in here. Linstor only does block storage. There is no object, there is no file in it, only block, because this question always arises, so I just wanted to clarify that one. I mean, if you count NFS as a file storage, yes, we can, but I don't know if you count it. And this is the Drbd architecture that I just mentioned. So Drbd is a very old technology, like 24 years. It has been founded by our founder, Philip Reisner. And this is an actual replication, real-time replication technology, which is running on any Linux server. What it does is basically, so you put the Drbd on each machine. It's a kernel module. You just load it, modprobe, Drbd, that's all, nothing else. And then you provide a block device below the Drbd device. So Drbd basically takes that block device and puts another block on top of it. It's a transparent layer. And then creates another block device for you, which is called dev/drbd something, 1000, 1001. It depends on your configuration. And what happens is the application or pod or VM, you can imagine whatever it is, it doesn't matter. When it tries to write that Drbd block device, what happens is the primary Drbd takes that write I/O, hands over to the TCP IP or RDMA or NVMe over Fabric, the transportation model, again, on your choice, hands over it, and then writes it down to the secondary Drbd. And the secondary Drbd on another machine, can be a physical, virtual, writes it down to the actual storage, get back to the primary with a confirmation. So with this way, this is a synchronous replication, with this way, we always be sure that whatever you write on the primary is also written on the secondary. And this replication technology, the Drbd, it stands for Distributed Replicated Block Device. This replication technology helps us to provide you performance at any level that your backing storage provides. So the thing is, there will be some bottlenecks. For instance, if you have a 1 gigabit line between the servers, and if you try to write this Drbd in, let's say you have an NVMe here, like 6 or 7 gigabytes per second, then this networking link will be your bottleneck for sure. Because the write I/O cannot keep up with the secondary here because there's a block in the network layer. So Drbd doesn't distribute your data like Ceph, for instance. It's not distributing. It's just replicating. You can think of it like a RAID 1 array over the network. That's what it does. So when you have a pod, or when you have a VM, or any other, in your system, so it is real-time replicated into another node. So when something happens on one physical machine, what happens is your 100% of the data is present on the another node. So there is no recalculation, there is no rebalancing, there is nothing else is working. It's just there, plain 100%. What happens next, obviously, a recovery will start. Then your Linstor installation will create another replica for that resource because now you lost one of your replicas, right? But that comes in time, obviously. And this is the Linstor's architecture. So the Drbd is the first thing that we created 24 years ago because the only requirement was to create highly available applications, such as databases or NFS shares or any other. But in time, obviously, there are orchestrators, operators, virtualizations, right? These things came into our world. And you cannot simply create a Drbd device by hand every time when you need a virtual machine. So you need an orchestrator for the Drbd layer as well, because Drbd is just a kernel module. There is a configuration file in every Linux machine for every single resource that you want to create, and you cannot keep up with creating these resources by hand. It's not possible. So that's why we created Linstor, I believe 7 years ago. the Linstor is the controller mechanisms for the Drbd and some other technologies I will explain in a minute. So Linstor has two components. The first one is the controller, and the second one is the satellite. What you need to do is you need to put controller somewhere because it's not in the data plane. So you can put it into a VM, into a bare metal machine, one of your worker nodes. We don't care. You don't care either because it can be highly available in any place. And the data path, it's not going through the controller to the disk. So you can even shut down your controller while your data is up and running without any issue. This is one of the great features of Linstor. And the satellite, Linstor satellite, needs to be installed in every single machine that you have. It can be a storage node. It can be on compute node. It doesn't matter. You have to install the satellite. So with these two components, the Linstor is complete. However, you need the CLI, APIs, and drivers to connect whatever you created in here to your Kubernetes or OpenShift or whatever you think of. And the Linstor's communication between the controller and the satellite can be interrupted, and it won't affect your data because the data plane is completely on Drbd. You can upgrade, downgrade, I don't know, remove completely the Linstor from your system. Nothing get affected about that. And what is Linstor is doing? So Linstor is providing you a storage allocation. So you can start from 3 nodes. It can be only a minimum of 3 nodes because of this split brain situation. So 2 nodes is not recommended at any given time. And it can go up to thousands of nodes. It depends on you. Because every single Drbd is a pair. By the way, I said 2 copy, but it can be up to 32 copy. It doesn't have to be 2. You can create 3, 4, 5 copy per resource. With that saying, you can also create some disaster recovery situations. Like, for instance, you have 2 copies on one data center, another copy on another data center. So kind of a setup can be possible. Like, for instance, you can also have the different connection types. In your data center primary, you can create synchronous replication while you're doing asynchronous replication to the secondary data center, if your bandwidth is good enough or latency is good enough. If you don't, then we have other options like snapshot shipping. You can ship the deltas in between times for the resources. And so you can create different policies within Linstor. Like you can define your racks, you can define your data centers and so on with some settings in the Linstor. So you can say like, okay, I want 2 copies of this same data, but one of them in one room, the other one is in another room. So you can differentiate your replicas in between 2 rooms. And the networking I just mentioned, there can be many, doesn't have to be only TCP. We recommend you to use the TCP if it's possible, because nowadays TCP is more than enough for many workloads. But if you're looking for a better alternative or more performant than TCP stacks nowadays, we support other ways as well. And obviously, the continuous data protection is possible with Linstor, because I just explained you can create disaster recovery scenarios with the Linstor setup, if you like. Okay, I didn't mean efficient, but it is efficient. So let me explain what do I mean by saying efficient. Drbd works in kernel, and this working logic helps you to get over some performance issues. Every single resource of Drbd is running on one CPU core of your kernel. So there won't be a huge impact on your CPU usage. That means that Linstor is perfectly fitting on hyper-converged environment. It doesn't mean like you cannot use disaggregated storage stacks. That's also perfectly suitable. But if you are thinking to create some hyper-converged environment, Linstor is really, really efficient on that. And there are some numbers that I can share you with, by the way, like how much impact that you have on the CPU. And minimal latency for block I/O operations. I just mentioned it's a benefit of having these replication technologies running in the kernel in a single CPU core. That means like every transaction for the I/O is happening in one single core. You don't even go to the CPU bridge for the I/O operations. It's just happening in one single core, which gives you a minimal latency for the I/O operations. And that's why we have many financial customers for that, because they're striving to have obvious performance on their environment, and Drbd helps you to do that. And optional load balancing for reads, that's really interesting feature, to be honest. So since we are creating two replicas of the same data, Drbd can be configured, or Linstor can be configured to read from both. So you're already writing to both, because every write I/O needs to be replicated so you can have the same data on both sides, but you can configure these two systems to read at the same time or in a loop, like round robin or any other. So with this way, you can have a really high read IOPS from your system if you are, let's say, 80% read, 20% write, or similar. With this way, it is really efficient on reads as well. And built on existing components is really important feature. So again, the Linstor doesn't do anything by its own. When you require a replication, it uses Drbd. When you want to use some sort of volume management, it uses LVM or ZFS. When you want to do encryption, it uses Lux. When you want to do deduplication, it uses VDO. When you want to have a caching mechanism, it can leverage Bcache, DMCache, and so on. So what we do with Linstor, we are using the existing components in Linux. We are not creating anything from scratch, except Drbd. Drbd has to be there. Apart from the Drbd, every tool that we use to provide a persistent storage is already in the Linux ecosystem. So when you remove the Linstor out of your system, the tools that you will have, you already know what to do. And the data is reachable there. You can mount and use the Drbd devices at any given time, so there will be no data loss at any given time with Drbd. And again, I mentioned the hyperconverged. It is very well suitable for the hyperconverged deployment. You can use it for reduced latency because it will read from locally by default. What was it? Not here, maybe. Oh, here. Optional load balancing for reads was an optional thing. So normally it only reads from locally, so it will really reduces your impact on the latency. And again, it's about 0.5% a single core consumed Drbd under heavier I/O. It's under heavier I/O. And all participant machines have full replicas. That means every volume will be replicated, so you don't need to worry about what if I lose one of the nodes. You have the data in your system. All right, this is the LINBIT's Kubernetes Stack. There are some other things as well, but I can only fit these in here. So obviously, we are using the CSI driver for the implementation. And there's a Linstor operator that you can use to deploy Linstor completely in your Kubernetes environment. This is a wide topic because, so I told you like it is an open source product. However, if you want to test the operator, not the Linstor itself, the operator, the Linstor's name is Piraeus Storage. The Piraeus Storage is Linstor completely, everything the same, but for the open source operator, this is the name, this is the branding that we choose. So when I say Linstor operator, it is also a Piraeus Storage, okay? It's the same thing. And we implemented Stork for the disk localization because you want it for the hyperconverged environment, obviously. And we implemented Customize for the unconfigured YAML files. The Velero, obviously, backups for the backups that you would require. Hopefully, you don't need to restore them at any given time. And also the Kubernetes implementation because on some of the cases, KubeVirt is a really important tool for the Kubernetes stacks. All right, so the takeaways from my presentation. So LINBIT is an open source block storage pioneer with 24 years of experience. When I say 24 years, everybody excited about it, and like the first response was, we never heard of LINBIT before. I mean, how come? There are many reasons for that. The first reason is LINBIT was mainly focused on working with OEM agreements back in the days. We worked with big giants like Amazon, IBM. We are still working. Amazon, IBM, Google, Apple, Western Digital, and so on and so on. You don't know, but these giants are using our own solutions, including Drbd and Linstor, beneath their providing systems. So most of the services in AWS is using Drbd for the block replication. And IBM is using Drbd in many boxes that they have, like MQ and so on. So, but we decided to change it, like around 10 years ago, and now we are trying to publish ourselves more into the community. And performance and scalability are the key criteria, and the LINBIT is leading the market on both fronts. Again, we are really good at providing the performance on any given time with your existing environment. So if you think that you are not getting enough from your hardware with the existing software-defined storage, I encourage you to try LINBIT and let me know the results. If you still have an issue, let me know again, so I would be happy, we would be happy to help you troubleshoot it. What is the reason that you are underperforming with the existing storage? On most of the time, we found a bottleneck on the hardware. When we fix it, it's more than enough for many customers in the market. And yeah, so LINBIT is here, and LINBIT is 100% founder-owned company, and we don't want to change it, and we won't change it. That means, we would like to serve the open source community as we can, while obviously we are gaining some enterprise customers as well to live for, yeah. And thank you so much. This was my presentation. I hope you like it. And if you have any questions, I would be happy to hear.
Thank you. Yeah, if you have any questions, please raise your hand. Are you sure there are no questions? Ah, there. I didn't see you.
Thanks for your presentation. Actually, my question is that what is the difference, main difference between your solution and other software-defined storage like Ceph? Because I think some other SDS use DRDB. What is the main differences?
Okay, so I believe there is only 2 open source products in the market as of today. If there is more, please let me know. The first one is Ceph, and then the Linstor. These are the 2 only open source products in the SDS market. So this is the first difference with the enterprise ones. And the second difference is obviously the performance. There was a competition between all SDS vendors. Some of them joined, some of them not, we win the prize with 14.9 million IOPS with the given hardware. And after 1 year, we changed that value to 25.5 million IOPS with some optimizations again with the Drbd. So I can clearly say that we are the fastest block storage vendor out there. This is the really an important feature for us. And the second one is we are open source. And third one is, I believe this is really important. And we have some customers also in the audience. I believe they will also agree this with me. I have been working for storage companies back in the days. I had a SaaS solution in Turkey, and I have worked with NetApp, HP, IBM, and many storage vendors. And if you ask me what was the problem with all of these vendors, I could clearly say like the slowness of their response when something really went off. So when you require a feature, when you require, it's not a big deal, right? When you require a feature, when you require something that needs to be done in your software-defined storage, and if you ask it from a big brand, most likely the response you will get is like, okay, we will decide in 1 year. I don't know if it makes sense or not. And if it doesn't make any sense, they don't do it. But it's totally different in Linstor. We added so many features just because an open source user wants us to do it. We added so many features just because a customer of us wants us to do it. If it makes sense, if it's logically possible to do it, we definitely do it. We put it into our pipeline immediately, and we add it into our software and release it for everyone, not just for that customer, obviously. So I can say like we are more flexible than any others in the market. I have been doing POCs all the time. This is one of my job requirements. And we added also features just because a POC user decides to have some features in their Linstor installations. Because it makes sense, and we didn't think of it before, we added in days, not weeks, not months, not years, in days. And that doesn't mean like we are not truly testing the feature, but we are doing it. But it's really important for us to listen to the customers, what they want, what they really need, and we definitely add it into our software. This is, I believe, the main thing that I can say. And when something goes wrong with your storage, which is possible. I mean, these things are not meant to be lived forever, right? There is a possibility that things go wrong. But when that happens, you need someone that hears you, understands you, and tries to fix the issue. And one single word about that, our support team is not a support team. It's the developers who built the Linstor. This is how we support the customers. If something goes wrong with a customer installation, you will touch the guy who wrote that code immediately, right after you create a ticket. So we are not putting a layer in between the customers and the developers, because we want the problems to be solved immediately so the customer can feel safe in their systems. That's what we do.
Thank you.
You're welcome.
Thank you. Any other questions?